Everything vertically is happening because something outside the function changed. Okay, so that's one thing we want to memorize, is that anything that is affecting the graph horizontally comes from what's inside the function, whether it's inside the absolute value, inside the parentheses that are squared, underneath the square root, and everything that's affecting it vertically is outside the function. So we talked yesterday about the vertical stretches and shrinks. Today we're going to talk a little bit about the horizontal stretches and shrinks. And they're a little bit more, it's like the opposite. Just like with the opposite translation, when it said minus, it went to the right when we wanted it to go left. And when it said plus, it went to the left, even though we wanted it to go right. The horizontal shrinks and stretches are also similar. Everything's happening opposite. Okay. So we're going to add in to our paper the absolute value of b times x. The factor a from above is 1 over b, so the reciprocal. So to identify the factor, we look at the reciprocal of b, which is the number that's getting multiplied inside the function. And then it's the same thing. It's the horizontal stretch if a is greater than 1, and it's a horizontal shrink if a is between 0 and 1. Okay, let me zoom in for you. With the vertical shrink and stretch, we talked about when we multiplied by a number greater than a, it stretched the points away from the y-axis. And then when it was between 0 and 1, it shrunk it closer to the x-axis. I'm sorry, I said y-axis. It stretches it away from the x-axis and closer to the, shrinks it towards the x-axis. When we talk about horizontal, right, vertical is away from the x, but horizontal would be away from the y-axis. So a stretch would be stretching it away from the y-axis, and a shrink would be stretching it closer to the y-axis. Yes?
So the horizontal shrink being 0 is less than a, which is less than 1? Is that what you're trying to put?
That's what I put. The shrink, horizontal shrink if 0 is less than a, less than 1. If it's between 0 and 1. Remember, we don't look at the negative sign because the negative sign does a reflection. Okay. We're going to look at why the order matters. We're going to look at doing 2 translations at the same time and how it affects it. Shifts left and right go first, the horizontal translations. The horizontal and vertical shrinks and stretch are the second thing we describe or perform. The reflections are third, and the vertical translations, shifting up and down, is fourth. So this is your horizontal translations, and these are your vertical translations. So we have these points on a graph, okay, and we want to be able to show what it means to do each of the transformations. So what we're going to do is first describe it in order, and then we're going to perform it. So, when I have number 1, how would you describe negative f of x? F of x could be absolute value x squared. It doesn't matter what the function is. Okay, in this case, it's this point. Okay, so what does the negative outside the function do? It reflects it in what axis? in the x-axis. So reflection in the x-axis. Right? The negative on the outside makes makes the y value negative, so it reflects it in the x-axis. So where is this new point going to be?
Negative.
Right. Is it 2, positive 3?
Mm-hmm.
So it's going to go to 2, negative 3. Because that flipped this point over the x-axis. Yeah?
So when the negative is on the outside?
When the negative's on the outside, it flips it over the x-axis. Bless you. When the negative is on the inside, how does it reflect it? Right, reflection in the y-axis, which means it's going to go like this, right? It's going to flip over the y-axis like this. So where's the new point?
-2.
-2, positive 3. So the x value is what changes sign. Because the negative is on the x. So it's changing all the values of the x values, changing all the positive x values to negatives and all the negative x values to positive. So it's flipping it around that y-axis. Hold on a second. My daughter got stung by a bee earlier today, so this could be the nurse. And we don't know if she's allergic or not yet. Hello?
Quiet.
Frickin' Greg from Auto Service Protection about my home warranty or my car warranty or whatever. So annoying. They call you now from a number like in Lake Elsinore. That's the only reason I answered. It said Lake Elsinore, so I was like, oh crap, I don't have the school's numbers in my phone, so that could be them. So far, we think she's okay. So, okay. So, again, one of the things we need to memorize is when it's inside, it's horizontal. Okay, so whenever it's inside the parentheses, inside the absolute value, inside the parentheses that have a square, underneath the square root, that is inside the function, and that is going to be something horizontal. Okay, horizontal is right, left. This moved it, right? Right and left. It moved it horizontally, right? So the reflection on the the reflection on the y-axis is horizontal, and the reflection on the x-axis is vertical. That's outside. Outside the function is vertical. Inside the function is horizontal. Okay? Now, how would we describe f of x plus 2? Horizontal translation. Left. How many units? 2
When you
units.
said outside, the what is?
Outside is vertical. Inside is horizontal. Horizontal is right, left. Okay? Here's the other thing to memorize. Adding and subtracting is a translation. Horizontal will be right, left. Vertical is up, down. Adding and subtracting is a translation. Right, left, or up, down. Right? Outside is up, down. Inside, right, left. The multiplying is your shrinks and stretches. Multiplying by x, multiplying outside is your shrinks and stretches. And then the negative is your...
Why don't you call it a horizontal translation, 2 units left?
Left 2 units left, because I don't want to write that much. Okay? It's okay. You can write 2 units to the left. You can write left 2. All means the same thing. Okay?
I tried to do it last year though when I put a horizontal translation, 2 units left, like that, for example.
That's fine. That's not incorrect. Okay? I'm not going to be that particular about how you write it. If you write 2 units to the left, or you write left 2 units, I'm not going to make it, that's both correct. Okay? I'm not that picky about things, and it drives me crazy when teachers are. But I just don't argue. Multiplying is shrinks and stretches. Okay, so if I'm going to move these 2 to the left, this is going to go where? Whoop, whoop. 0, 3, right? 2 units to the left. That's an ugly arrow.
Why are you going to the left and not to the right?
Because it's opposite, right? Remember when we did it yesterday, we put in +2 and it went to the left?
Yeah.
And when we did -2, it went to the right? Horizontal is always opposite, right? It's always opposite of what you want it to do. You want +2 to go right, but horizontal is that kid that always defies you and it's going to go the other way. So it's going to go left instead.
Oh my God, it's so cold.
Okay. Are we good with these three? Yeah? Okay. All right. Outside the function is vertical. Adding and subtracting is shifts, translations. So adding outside is up and down, right? So we would call this a vertical translation up 2, or 2 units up. You can write the whole word out. You can abbreviate V trans up 2, save yourself a little bit of time writing. That's okay. So I'm going to take this 1 point and we're going to move it up 2. And now we are at 2,5 instead. Okay, so the vertical translation up 2.
Is that it?
Yep. If I had a whole graph, I would move all of the points up 2. And that's where my new function would be. Now, number 5. If we go by the order in which we are to describe, we describe reflections first. Well, third technically, but I only have a reflection and a vertical translation. The reflection is going to happen before the translation, and I'm going to show you why we have to have a standard order in which we do things, because if we don't, we get different answers. Okay? So we have the negative on the outside, which is a reflection in what axis?
X.
Good. Reflection in the x-axis. And then +3 on the outside is what?
Up 3.
A vertical translation up 3. Okay? So we're going to do it in that order and see where we end up. And I want to show you how then we end up in a different spot if we pick a different order. So first I'm going to reflect it in the x-axis, which means it goes from the -1 here to +1. So that's my intermediate step. We're right here. And then from there we're going to go up 3. There's my final point. We'll put the final point in red. Okay. So we reflected it on the x-axis and then moved it up 3. That's the proper order. If we were to do it the opposite way, okay, if we were to go up 3 and then reflect it, it would be down here at -2, which is not where we wanted to end up. Why is this at what?
4.
Because I'm reflecting it in the x-axis, so I'm going from -1 to +1,
Okay.
and then I'm moving up 3. So first we flipped it over the axis, and then we moved it up 3. If I went the other way, if we went up 3 first, we'd be at 1, 2, and then reflecting it would bring it back down to -2, not the same point. Okay, so when we have situations where if I do them in different orders, I get different answers, we have to establish a proper order so we all get the same answer at the same time. Okay. So the correct order would be to reflect it and then translate it. Now, let's look at the next one. F of -x minus 1. Well, the order is the horizontal translations, then reflection. So inside, everything is horizontal, and this is where the order becomes really important. If everything you're doing is horizontal, you have to do it in the right order. If you do a horizontal thing and then a vertical thing, you could do them in a different order and you're going to get at the same spot. But if I do something horizontal and then I do something horizontal again, the order is going to make it end up different spots. Okay? Because that's the order we've established. At the top of your paper, it says horizontal, right, left, right shifts, which is horizontal translations. Then shrinks and stretches, and then reflections, and then the vertical translation. So vertical translation will always be last. So for this one, we're going to need to do the horizontal translation first, and then the reflection. What is my horizontal translation when it's -1 inside?
Yeah, right. Oh, to the right.
To the right, 1. And then what is the negative inside? Reflection in the y-axis. So we're going to take our point and we're going to move it to the right 1.
Why is it reflection again?
The negative in front of the x. On the inside is a reflection in the x-axis. So I'm going to move it right 1. And then I'm going to flip it. I'm 3 away from the y-axis. I need to go 3 away on the other side. So we moved it to the right 1, and then we reflected it over to +3 from the -3. And that's my final points. Now, what happens if I did it the other way around? If I reflect it first in the y-axis, I go from -4 to +4. And then if I go right 1, I'm at +5, not the same point. Right? So the order is really important.
I actually like to do the reflection last.
When you look at the order at the top of the paper, right? You look at what you have. So you're going to first talk this, you're going to describe it in the correct order, and then you will perform it in that order.
That makes sense.
Okay, so if there isn't a shrink and stretch, you skip that one, right? If there isn't a vertical translation, we skip that one.
So this is important then.
Now we're going to look at the points and a vertical and horizontal translations. Okay, we have a 2 times f of x. That's a 2 on the outside. If it's outside, is it vertical or horizontal? Vertical. And it's being multiplied, so it's a shrink or stretch. Okay, multiplication is a shrink or stretch. Addition, subtraction is a translation. That's your left, right, up, down. Okay, so we know it's a vertical something. What's the factor? What's the factor?
2 is greater than 1.
Factor is 2, right?
Oh, yeah.
Vertical doesn't do anything funky. I don't have to flip anything, change any signs. Vertical is just the way it is. 2 is my factor, which is greater than 1, which makes it a shrink or a stretch. A stretch. So it's a vertical stretch. Factor of 2. Okay, what that means is this distance, the vertical distance between the axis and the point, gets stretched by 2. So if this distance is what? 3. What is the new distance going to be?
Is it added by 2 or
Multiplied
multiplied?
by 2.
Oh, 6.
6. Okay, so we are doubling it by multiplying it by 2. So overall, we have multiplied the distance between the axis and the point by 2. So my new point is up here at 3, 6. Okay. Say that again?
Why was it a stretch again?
Why
Why was it a stretch?
A stretch, because the factor 2 is greater than 1. Remember, if a is greater than 1, it's a stretch.
Yeah.
And if it's between 0 and 1, it's a shrink. Okay. Yes, Gabriel. This distance between the point and the axis is 3. And a vertical stretch factor of 2 doubles that distance. So I'm going to go to 6 instead. So I'm going to double that and go to 6 instead. I guess my drawing could be better. That's 3. So my new one is going to be 6. Is that better?
Yes.
Okay. So let's look at 8. Outside is still vertical. What's my factor? 1/3. It's important that we identify the factor and then determine shrink or stretch. Okay? So if the factor is 1/3, is it a shrink or a stretch? It's a shrink. That means this vertical distance between the axis is -6. Well, the distance is just 6. We learned that about absolute value, right? Distance cannot be 0. That distance is shrunk to 1/3 of what it was. So 1/3 of 6 is 2. So it shrinks to 2. 1/3 of the distance. So your new point is at 5, -2. So a shrink moves the point closer to the axis, and a stretch moves it farther away from the axis. Right? Okay, so now here's the really new stuff. Inside is horizontal or vertical? Horizontal. It's inside. That means my factor is not what it shows me. I have to do something to it to get my factor. I have to take the reciprocal to get my factor. What's the reciprocal of 2? 1/2. Okay. The reciprocal of 2 is 1/2. Flip the fraction, right? Put a 1 underneath it, make it a fraction, flip the fraction. The reciprocal is 1/2. Now, if the factor is 1/2, is it a shrink or a stretch? It's a shrink. Does that mean it's going to get closer to the y-axis or farther away? Closer, right? Half the distance. It's currently at 6. Where is it going to go? Half the distance of 6 is 3. So it's at 3, 3. Notice we're changing the distance from the horizontal distance from the y-axis.
Because it would inside means it's a horizontal factor 1/2.
Correct. Because it's inside, the factor is the reciprocal, and it's horizontal. So that's why it's 1/2, not the 2 we're looking at. So again, number 10 is also inside, right? So it's horizontal. The factor, if it's horizontal, if it's inside, the factor is the reciprocal. The reciprocal of 1/2 is 2. If the factor is 2, is that a shrink or a stretch? It's a stretch. So that means the horizontal distance that is currently 3, it's going to get multiplied by 2.
Took the reciprocal and made it 2, so it's a stretch instead of shrink.
Correct. I am struggling right now to make a curly brace. There we go. My curly fry. the original dot is at -3, -3. The final, after we've stretched it horizontally by a factor of 2, is at -6, -3.
So you multiply 2 by 3 to get
Yes, multiply that horizontal distance by 2, because we're stretching it twice as far away. Okay. Number 11, y equals the absolute value of 2x is my transformation inside or outside of the function. Inside. Inside is vertical or horizontal? Horizontal, so we're going to circle horizontal. Okay. Horizontal, do I have to do something to get the factor? Yes, I have to take the reciprocal of the number I see for horizontal. So if the number is 2, what is the factor?
1/2.
Factor is 1/2, which makes it a stretch or a shrink. A shrink.
Is it just a shrink because it's a fraction or because it's less than...
The fraction is less than 1, yes. Because if the fraction was 5/2, it would be a stretch. Yeah. Has to be between 0 and 1.
What is the reciprocal? What can we just do like this?
Because it does it affects it by 1/2. It shrinks it and it makes it half the size. Or more like it's dividing by 2 instead of multiplying it by 2. So, but once we get into dividing by a fraction, we'd rather think of it as just multiplying by the whole number. Okay, number 12, 0.35 times the absolute value of x. Inside or outside? So is it vertical or horizontal? So what is my factor? Now the factor is 0.35. So identify the factor and then decide whether it's a shrink or a stretch. It's a shrink. Why? Less than 1. Okay, what about, I'm running out of time here. What about number 13? Vertical, why? Because it's outside. What's the factor? No. The factor is just 3.
Why?
The negative sign reflects it. The negative sign does not affect the shrink or stretch. Okay? So the factor does not have a sign on it. The factor is just 3 here. Okay? And so that makes it a stretch.
So if there's any negative on a number, you just don't.
We just ignore the negative when we're talking about shrinks and stretches. But make sure we address the negative as a reflection either in the x-axis, vertical, right, or the y-axis when it's inside. Okay, number 14. Vertical or horizontal?
Horizontal.
Why?
Inside.
Because it's inside. What's my factor? 7 over 2. Right? If ever I think it's horizontal, I have to use the reciprocal. The reciprocal of 2 7s is 7/2. Does that make it a shrink or a stretch? Stretch because it's greater than 1.
Oh, you only do the reciprocal on horizontal?
What?
You only do the reciprocal, like you only flip them all horizontals?
Yes, I only flip it for the horizontal
When they're inside.
Yeah, next.
when it's inside. Okay, 5/4 times f of x. Vertical because it's outside. What's the factor? 5/4. That makes it a shrink or stretch. A stretch because it's greater than 1. And then lastly, f of 1/4 x.
Horizontal.
Factor of 4 or 4 over 1, which makes it a stretch.